YouTube channel? Can someone? Thank you. I think it's working. I think it is working. Okay, we're about to find out. Now plug this in. Nice. Oh, and we will start going. Can you hear us? Hello. 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 What about now? Hello. How's it going? Okay, perfect. You just have to speak like this. Okay. Perfect. All right. Okay. Hey, what's up? So for the stream, you're gonna speak like this because the mic is right here, and the stream who means computer because he doesn't have a mic. Just stay close to the computer when you're speaking. Does anyone have a mic? Don't worry about it. That will work. That will work. That will surprisingly work. Oh, it's because I'm loud. It's because I'm loud. Is it making the rest of us? Wait, hold on. Is the link home? Yeah, but at least like put it here. Yeah. Oh my God, using HyperX. Yes, I have a USB.
So there's like a mic to this. Maybe this could work.
Okay, never mind. All right, don't worry about it. Go back to what you're doing. We'll start in like 5 minutes. I'm giving them 5 minutes to start. After 5 minutes will be another 5 minutes.
I guess just hold it.
Okay. All right, Naveen. All right. How's it now? Is it working at all? Yo. Is it connected to the thing? Okay. Add the audio device. I might be still connected. Okay.
Oh, no, it is great.
Okay. As long as there's audio going, can someone, while they're not up here, both is fine. Watch the chat. Watch the YouTube chat. One of you two. Okay, perfect. Thank you. All right, we've unplugged it from this. We don't unplug it from this because it works through here. Yeah, it's just delayed. All righty.
One quick question. One thing, if you check your Discord, I sent you my presentations. So, did you tell me or?
What?
So I'm gonna be presenting, I think, in the beginning, somewhere like after. Yeah. So like, yeah. So like, I said.
Okay. Can we close this out? You're screen sharing this right now. No, he is streaming from his laptop, not just to the screen.
Oh,
Don't put that in the YouTube chat.
hey, can you scroll down a bit? Scroll down, all the way to this.
Okay. Okay. Now we hit present. We should be. You guys should be good to go. All right. All right. Hello, stream chat. I don't know if anyone is in there right now, but hello. We're gonna get started very, very shortly. We were just having some technical difficulties. All right. Yeah. Like he said, welcome to the spring 2023 ACM Research Intro Session. I'm gonna let these guys do their thing, but thank you all for coming out. It means a lot to them. It means a lot to me. It means a lot to Jocelyn in the back. Thank you so much. We hope you'll all apply because this program is great. And I'm gonna let them take it away. Yes. Yeah.
So, hey guys, welcome to the ACM Research Interest Meeting Spring 2023. This is our first ever interest meeting, so I really appreciate that y'all are here. So since it's already late, might as well just get started. So let's get started. So what is ACM research? ACM Research is basically a guided technical research project initiative. We are here to basically kind of tell you how CS research works, and hopefully in the future you can join labs with like your professors or just any RUs outside of campus. And this is like the best gateway to eventually doing that. ACM Research specifically is a 12-week program. So we'll have about 11 build nights, and then the 12th week will be a final symposium. So you will be kind of presenting your research project there with like a competition and with an audience. You know, you dress up fancy, kind of like a industry kind of event. And so our build nights, we meet every Monday, 8:30 p.m. to 10. During these build nights will not be the only chance you'll be working on your project. There might be times where you will be working outside of the build nights, but that's really just dependent on your team and how it works. And each team will have 5 participants, a student research lead, which is all of them right here, and a UTD professor to go along with it. I will get into all that in a second. So, what do research leads do? The research leads are basically your managers for the project. They kind of guide you over, you know, the what you're doing in the project, the different tasks, and all that. They also do our leads are designed to kind of mentor you on different tools that you might be using in your individual projects. For example, when I was a lead, I had a project that was heavily using TensorFlow. And so I had like my participants be like, hey, kind of learn what TensorFlow is, how that works. So they'll be teaching you all these different tools. We also encourage our leads to kind of give you research papers so that you are able to kind of just know about the different research opportunities in like the related to the specific project that you're doing. And they also coordinate with like your the professor that will be assigned for individual projects about like project progress and meetings and all that. Keep in mind, your research lead will never be doing the actual project itself. It's just more purely like a management role. They will never be coding. They won't. They can help you with the code, and you know if needed, but most of the work will be done by the participants themselves. Like and yeah, so that's yeah. Build nights. So these build nights, like I said, are 8:30 to 10 every single Monday. They're designated times to work on your research projects. Some of these build nights will also include built-in workshops. So you know, I might just have y'all just stop your projects for like 20 minutes in the beginning of a build night just to talk about like you know how to do like public speaking or you know just any lessons that you might need for you know our research symposium or just in research in general. These build nights will just be with your team and the student lead. Your professors will not be coming. Professors will professors will be doing bi-weekly meetings. So they will not come to the build nights, but you will meet with them outside of your build night. You meet with them every other week, and these professors are here to kind of just help you guide your project as like a research lead would do. But since they are more experienced in the field and more experienced in the specific topics of your project, they have more like, you can do this, maybe use this kind of machine learning instead of that, or just you know tips and tricks like that. Professors also do not like code just like how a research lead do. They're purely there just for guidance and career advice and giving input on like the best direction of the projects and practices and whatnot. In addition to build nights, we will also be doing 4 workshops. So these workshops will be happening about being every 2 weeks. There'll be 4 workshops this entire semester, and they'll be on like a Saturday night. So I mean, it's kind of an inconvenience, but I really feel like these workshops are filled with good stuff that you can learn. Our current workshops that we're going to have this semester is machine learning and more, which is kind of like an ML introduction to ML, how it works, the applications and whatnot. Our second workshop will be about research and how you can do more research at UTD or even just outside. You know, different internship opportunities that are happening in the summer and whatnot in relation to research. We have a code debugging workshop to teach you how to debug your code if you're ever stuck on that. And then the fourth workshop we haven't decided yet. If you apply and get in, you'll find out what the workshop is. So these workshops will be taught by the research leads. We will have them kind of, really learn about the topic that they're teaching, and then they'll teach it to the people that attend the workshop. And we'll also sometimes have like people from various Fortune 500 companies come in and also participate in teaching and whatnot. With the workshops, we also have socials. So the socials usually happen right after the workshops. This is just kind of like a fun hour to just to meet your other research participants. We also do a couple of socials with ACM projects or ACM education, which is like the TIP and mentor mentee programs, so that you can just meet more people within ACM or other CS majors. I know that the socials are really the best aspect of ACM, like any ACM program, because a lot of CS majors, you don't really socialize with them, especially in your classes and stuff. So the socials are a great way of meeting people in like your major or that share the same interests in you. These socials are for ACM research members only, so you should apply if you want to be in these socials. But our workshops are free for everyone, even if you're not in the program or not. So if you end up not getting in, you can still attend our workshops. Um, and finally, our final symposium night, like I said, we'll be having that at the end of the semester. It'll be Monday, May 1st. And the way these symposiums work is that we will have all 10 teams kind of present their projects and what work they did throughout the semester. And then there'll be a judging panel consistent of different UTD professors, industry mentors, and ACM's faculty advisor, the GOAT, John Cole. And so they'll be judging the different projects that are coming, and then the winners will get a prize and a trophy and just recognition, like, hey, I won this. So before I introduce our team, I actually have a ACM Research old alumni that did the program, and he offered to speak with us. So I will let him take over.
Hello, everyone. How's everyone feeling today? Yeah. Okay. Thank you. That's the energy. Thank you. Thank you. All right. So now you guys have heard a little bit about what ACM is. So I want to show you from an insider perspective of what actually happens, and maybe you guys, give a little sneak peek of the little goods and trades that we have there. So first of all, who am I? I'm Abhishek. I'm a former ACM research mentee. Last year and last semester, I was a research mentor. So not only have I done a project like you guys will be doing, but I've also mentored a project like these guys. So I have like a bit of both, both of the skills there. So, why did I choose ASIM research and why I think you guys should choose ASIM research? One of the reasons is that it's an amateur experience of how professional research is. So, if anyone here is interested in going into professional computer science research, this is a good way to try to get the template of how that might work out. It's a good way to understand how research in general in CS works. There's a diversity of topics, so I know like the cliche that we only do machine learning, but we don't. We don't. We have explainable AI like from last semester and like finding security deficiencies. So if you guys have any different interests, we can also accommodate that. Freedom and control over your ideas. Best part is you can like go in a pathway. If it doesn't work out, you can do another pathway. There will be no repercussions or anything. And the most important one is your ability to leave your mark. These projects are really individual guided, so you have a great chance to leave your mark on the project and the results. So now let's get to what I have done and my team has done in the past. So this is from last year. This is extramural, and the kind of cliche that we wanted was helping Matthew McConaughey in Interstellar. The main idea was that we wanted to find out if we could determine exoplanets and what's in their atmosphere just by looking at some data from them. So this is some of the work that we did on that. We went through creating these things called convolutional neural networks. So you guys will learn all these things in this research program. And we had stuff like this. All right, so one question, hands up, who knows all these terms here? Gaussian, Coppola, whatever. Except for these people. Can I get a raise of hands of who might know these terms here? All right, good. No one. That's the point. We didn't know these terms either. None of my teammates did. And at the end of the program, we ended up finding out what these terms meant, and we were able to use them. So don't be scared as well, because this is a very introductory program, and the mentors are very good at helping you to get what you need. And just another kind of insight of what we did here. Um, this was last semester, YOLO v Cappy. Our goal was to find hidden capybaras. No, I'm kidding. It was just for like finding for cars. So basically, the idea was, can we use thermal imaging with cars to kind of detect what's behind the glares of car lights, and use models to kind of pick up those objects and whatnot. So this is some of the work we did. Thermal cameras, made the model. This kind of like, again, the mentors will guide you every step of the way. Not every step, but like, they'll guide you super well to kind of figure out how do you make these models, what's the understanding behind them. These are some of the results that we had. And I actually want to show you like a demo from last semester that I think is pretty cool. So I'm just gonna go here, go one slide back. So, so this is what the team came up with. Is there a way you can turn off the lights for just like 1 second? Yeah. All right. Cool. Perfect. Okay. So right now you can see like it's like you have glares. It's like a traditional like nightlife car activity, and our your model is able to pick up some of the things there, but there's a big glare and it's not really able to pick up. So after all of our research last semester, we were able to come up with something like this. So if you look carefully, you can see a kid, a person right here that's running through, and so our model was able to kind of pick those things up and pick those out and show it, so it can help in car security and whatnot. So yeah, so back to this. But yeah, that was kind of it. This is a little sneak peek at ACM, and I hope you enjoyed it. Thank you.
Thank you, Abhishek, for coming and speaking. And yeah, so now we are going to introduce our team. Hi, I'm Cece. I am a sophomore majoring in computer science, and I'm also minoring in criminology and material science and engineering. So, I have a lot on my plate. But yeah, I did ACM research back in spring 2022. I became a lead last semester, and now I'm a director, and I'm super excited to be here. Fun fact, we were actually in the same project from a participant. We both became a lead, and now we're both directors. So it's like, that could be y'all twins. Yeah, that could be y'all too. Yeah, and these are leads. We'll talk about it later. And then August is not here, but he's also one of our leads. He's doing the bare metal programming in 3D Euclidean space project, and I think he's a freshman in computer engineering. And then Crispy could not be here as well, but he is also he's the lead for the adversarial attacks project, and he is a senior in a senior CS major, I think minoring in public policy. Okay, so now we're going to talk about a little bit about the application, which is probably why y'all are here. So about the application. So our application is actually a two-step project process. For those of you applying to ACM projects, you probably know that's like a one-step, but we have an additional coding challenge. So the first step is the normal Typeform application. In order to do it, you must create the ACM portal account first, and then you have to do the application where we ask just general questions, like what clubs are you in, what experience do you have you taken certain classes. This is purely just to get to know you. If you haven't taken, specific classes that are on the application, that does not penalize you in any way. That's just to see more of like a statistical purpose kind of thing. Additionally, on our application, at the end, there is a Google form for division preference. So I know a lot of you all must be applying to ACM projects and ACM KIP as well with ACM research. So if you are accepted to all three, you can only interview for one. So that's why we ask that you fill out this division preference form, so that we know, like, if you did get accepted to all three, which one would you prefer to be interviewed for. And then we also have the coding challenge. So I know coding challenge is very daunting, and most people end up just kind of like freaking out and then just not doing it. But I'm telling you, the coding challenge is like it's supposed to be the easiest thing ever. It's very open ended. We basically designed it just to see pretty much how well you can Google. We give you like a data set and you kind of just classify it in your own way. It's really graded based on your effort. I know when I was a participant and we had a coding challenge, I didn't know anything about it. I kid you not, I wrote a 5 sentence paragraph on how to do it. And now I'm here. So you don't even need to code for it. You just need to show some sort of effort. This is purely just to measure your creativity, how well you can Google, like I said before, and just get to know you more as an applicant. Just a reminder, our application is due on February 1st. This is included with the coding challenge. If for those of you that have already submitted the application, you may have, like, you were supposed to put a link, which is like a fork of the GitHub repo for the coding challenge. As long as you submit that link, you're good. Like, we will look at your coding challenge through that link, and you have until February 1st, 11:59 to do it. Please submit the fork. We've had lots of applications that have not submitted a link to the coding challenge, and that is an automatic rejection because we have no way of knowing which coding challenge belongs to you. So please submit it. All you need to do is just it will have the link to the coding challenge on the application itself. You click on it and then you make a fork, and then you just put the link of the fork in the coding challenge, and then you're good. You can edit the fork GitHub or whatever like after until February 1st. So what do we look for in an applicant? Typically, we look for freshman and sophomore just because our program is more introductory level, and mostly freshmen and sophomores do not have, that much experience, but just the right amount of like interest and the basic like computer science classes so that they can excel in this program. With that being said, if you are a junior or a senior and you still like, we're not telling you you can't apply. We've had juniors and seniors apply in the past. Um, so you are perfectly fine to apply. Do not feel discouraged just because you're not a freshman or a sophomore. It's mostly just we're looking for like the classification is one of the last things we look at. We really just look at your club experience and whatnot. With that being said, you don't need to also have like built rockets at 15 or some crap like that. If this, like I said, this program is very introductory, so as long as you show that you have a passion and you're willing to, like, if you were in this program, you'd be 100% interested in learning the different stuff. Like, you are exactly what we're looking for, and so you will be fine. Addition to that, evidence of self-learning. We have this program. We will be teaching you things, but a lot of it is self-learning. It's like, well, maybe you'll have like a task in your project, and you don't know how to do it, so you might have to like watch like a YouTube video or just read something just so you can know how to do it. So that self-learning ability is very there'll be a lot of that in this program. So that's what also we're looking for. Any campus involvement, leadership roles. We love that kind of stuff. So we know that you can work well in a team communicate and just a willingness to put yourself out there and have fun. We also prefer that you have like basic programming skills, and what I mean by that is if you've taken like an introductory computer science class at UT or at community college, is you're good. Because while we are an introductory program, we still want our applicants to have a little bit of like programming skills so that we can build on top of that through this program. And effort in application. We love oh sorry. We love looking at applications that have like lots of details about your different projects and different experiences and whatnot, because we might not know like what the experience is. So if you go into detail, we absolutely love that. And so please make sure you put in a little bit of effort in the application and the coding challenge. So our application timeline is pretty standard. We have the application submission plus the coding challenge that's due on February 1st, and then after that, we will, for those of you that have qualified for the interview round, we will reach out to you and we will do interviews around the February 4th and 5th weekend, and the acceptance will be sent out after that, and our first bill night is February 6th. For those of you that do qualify for the interview round, I would just like to say, so we are scheduling our interviews on the 4th and 5th, and our build night is the 6th. Due to like external factors, we had to schedule it that way. So please check your emails for any emails about like if you got in or not, or when your interview is, because it's very last minute to when the first build night starts. It was something out of our control, so we're very sorry for that. But please make sure you just look at your emails. And application tips. Like I said before, please elaborate into your applications and go into more details about your experiences and activities, just so that we can know you better and understand you more as a person. By writing, like one or two sentences about it, like we only can get so much off of that. So elaboration is very important. Also, make use of the last question in the application. It's just a question that's like, tell us anything about yourself. We encourage you to please, talk about, your passions, your interests. We even had I had an application I read the other day. It was like, I like waffles better than pancakes, and my roommate's birthday is in 2 days. I'm like, good for you. We kind of like that stuff. So just, make use of that last question. It's just an external factor, just to, for us to understand you better. And also, one thing, you can include clubs and projects from your high school. I know, like, mostly freshmen and sophomore are applying to this program, so you might not have many experiences that were in UT. So you can put stuff that you did in high school as well. And so now we're going to be talking a little bit about the projects through our research leads. So yes, um, Argan, would you like to go first? Oh yeah. Yeah.
Testing. Okay. Hey guys. So I'm leading the rover optometry project this semester, and the idea is that if you're not aware, an ROV is a remotely operated vehicle, and it's usually used for like military, search and rescue, things where you don't want to send actual people, so people send out robots like deep underwater and like scope things out, do whatever they need. But for this semester, I wanted to throw on a model using like a CNN model where you would detect objects underwater, whether it be like pipelines, humans, or whatever it may be. But the challenge is that it'd be like under various levels of like the murkiness of water. And so, yeah, just have to work on that and hope that it works out. And also, I don't know if it's okay to say this, but I'm the outreach head for RoboSub. And so if this works, then maybe we could slap on to the ROV over there. Also check out the club. Let me know for more details.
Yeah, I'll be Chris. Hi, I'm Chris. So Chris could not make it today, unfortunately, but basically his project is about adversarial attacks to detect political disinformation models on Twitter. You're basically just kind of going, you're pulling information off of Twitter, and you are kind of seeing, testing adversarial attacks can be sorry, you're replicating adversarial attacks using information found on Twitter. So I don't know much about the project, but oh, I'm so sorry. It's been a long day. I will. Uh, so if you go on the application, you can see the list of the projects, and the actual description will be there. I'm so sorry about that. But that's basically the gist of it. Unfortunately, I don't really know much more about it. But if y'all want to reach out afterwards on Discord and whatnot, I can ask Chris to tell y'all more about the project. And
Okay, so the project that I'm leading is colored image translation with CycleGAN. CycleGAN is a form of generative adversarial network, meaning that you have a model that's generating images and a model that's trying to detect whether the image is generated or a real image, and they're learning from each other to do their respective tasks better. So I mentioned in the description a couple of potential applications of CycleGAN, which will be decided like by the participants, not by me. I thought that was an interesting idea. So I mentioned that you saw the thermal imaging project actually earlier, which is great because one use of CycleGAN is called image transfer, and we can take an image that's in normal coloring and then train a model to transfer that normal coloring image to thermal imaging so that we can more effectively detect things. The other idea that you might want to look at is X-rays. A lot of X-rays require staining before or after to like see specific details. So one thing we can do with image transfer is take it and stain it without actually physically staining it. So we can do it post facto, which reduces costs and makes it much more convenient and safe for the people doing it. So yeah.
Hi, I'm Rohan again. So I'm sure most of you have heard of crypto and blockchain with all this stuff going on recently. But this project focuses more on the infrastructure of crypto and blockchain specifically, more than the economic part of it. So pretty much, blockchain is relatively new, specifically chains like Ethereum, and they're special because you can build upon them. It makes way for a lot of innovation. Um, the reason why people can build on them is something called smart contracts. So what these smart contracts are pretty much just pieces of code that any developer can put on a blockchain, specifically Ethereum this time. And you'll learn what all of that means in this project. You'll learn about blockchain, what smart contracts are, how to put them on blockchains. So the main point of this is these smart contracts are written in a language called Solidity, and due to the nature of a blockchain, all of these smart contracts are open to the public. You can, just go on a website right now. It shows any smart contract you want open to the public with all the code, um, because that's what blockchain allows to happen. And this can get dangerous when you know, people make mistakes while coding, or they have like some logical flaws with their code, or just text flaws with their code, and it creates some security vulnerabilities. So this is especially dangerous because the nature of blockchain, they can be manipulated by anyone. This code can be accessed by anyone and can be manipulated and attacked. So you withdraw $1 million from smart contracts, stuff like that. So during this project, what we're going to do is analyze past attacks on famous smart contracts on the Ethereum network, and analyze the logical flaws that they had, which allowed for them to be manipulated. After we get to get familiar with Solidity and all this stuff and all those attacks, we're going to start to look for and try to find an undiscovered um, smart contract that has a flaw in it. And if all goes well, we'll manipulate it and hopefully get $1 million. But that's all.
So hello, my name is Aditya Desai. I am the research lead for the cardiothoracic diagnosis project, where we're using machine learning to go through cardiothoracic diagnosis. So what exactly will we be doing this semester? Well, we'll be learning and employing deep learning technologies and methodologies in a Python environment to create a model that can, at the end of the semester, be fully functional in taking any chest X-ray to procure
splenomegaly, pneumonia, COVID-19, tumors, and things like that. So what really makes this project unique or like applicable in the real world situations? First thing is quite comprehensive. So most models in this field are quite specified on a singular disease. So they'll be focused on pneumonia or they'll be focused on COVID-19. They don't do quite as many as we do. So this will be a lot more comprehensive. Another thing is it looks into things related to cardiac issues, which is not really like looked for in a chest X-ray, but this will help physicians in the future kind of focus their treatment plans. So that's kind of a brief synopsis of what we'll be doing in this project. But if you have any questions, feel free to reach out to me, and I'll be more than happy to help.
Hey guys, I know there's a lot of typos on here. I am so sorry. I'm just gonna refresh the page for a second. We just fixed it. Um, yeah. So yeah. Okay. That's Lawson.
What's up, guys? So let me ask this question first before I go into my project real quick. Do you want to do something that's bleeding edge? Like I'm saying, you want to be at the forefront of research right now. Do you want glory? Do you want passion? Because that's what I'm looking for you. I am looking for you right now, okay? If you were the smartest child at your school, what you believed in, thinking nothing. Because right now, I'm about to go in something that is bleeding edge. This is neural radiance field, nerf or nothing, I'm saying. So, what neural radiance fields is a new visual effects modeling kind of technology that uses a neural network to basically make an image using with light in the what part of it. And so, sorry, I just so basically what I'm saying is that we're poking into a neural network, asking at each like ray tracing. Okay, what should I see at this pixel? What's density? What's the color? And we can get basically a realistic model based with light from any angle of an object, given only a few couple pictures. So like let's say I take a picture of front of a chair, back of a chair, left of a chair, right of a chair. Then just from those four pictures, I can get a full 3D model that looks super realistic with light included in this neural network. And so this neural field technology has been it's very new. It started in 2020 and it's only been become more popularized through various technologies from video in 2022, and papers are still being made of it now. Hundreds and hundreds of papers. I think just this month, 3 days ago, another paper was made just how to make videos of nerves. But we're going even further with my project, with no ratings fields. If you're up to the challenge, if you really believe that you want to be on a paper, you want to be on your resume saying, "Sir, I did no ratings fields and I did a paper," you'll get hired easily 99.9% of the time. Okay, I'm not kidding. I'm really not kidding because this is it. And so I'm looking for you. If you're passionate and you think you're the smartest kid in the block, I want you. I don't care if you're junior, I don't care if you're senior, I don't care if you're freshman. All right, come to my project. I will teach you. I will give you all the resources you need. Be awesome here. Okay, and so I'm telling you, say, come to Nerf for nothing. We're gonna make no radiance videos that are VR. It's like an out of body experience. That's what we want to do. If you want to know more, you can read through there, or you can ask your questions later. But I'll go ahead and move on to the next one. I don't want to take too much time. All right, it's a little hard to top what Lawson did there. But okay, how many of y'all have played like some kind of two-player game before? And if you don't raise your hand, you're probably lying. so, if you guys have ever played chess, back in 2017, you probably have heard of this algorithm that Google developed with DeepMind called AlphaZero, and it knocked out like every major chess engine after 3 days of training. And the way it did that was reinforcement learning, and that's what I'm going to try to do in ACM research. So, like it shows there, chess, Go, StarCraft 2 for some reason, and Stratego. All these games have been proven with AI models that use reinforcement learning by playing against each other, playing against itself, actually. So, in the research project, I actually designed my own game. It's a really basic two-player game, but it was made in Unity. And Unity uses something special called ML Agents. ML Agents allows us to create machine learning models in Unity with the agents that we're given. So we're going to teach two agents to basically play tag, or a very interesting version of tag, mixed with capturing a flag, mixed with soccer because it was the World Cup a couple months ago and I was feeling inspired. So in
this thing, you're gonna try to get this guy to run around the goalie and score a goal. It's so you can see kind of the capture the flag analogy there. And we're going to teach the AI to play against itself and figure out the best way to do that. So if you guys are interested in reinforcement learning or some kind of game design, then feel free to join Agent Chase training opposing agents in Unity because I think it's a very cool, unique project, and I'm having a lot of fun building out the designs for it. So come on, join us.
Thank you, Naveen. Oh, whoa. Static. So August is not here, unfortunately, but his project is bare metal programming of an embedded system to manipulate rigid bodies in 3D Euclidean space. It is probably our only project that is not machine learning, and it's very math heavy, like low level programming stuff. So if that's something that's interested in, please apply to August project. Once again, if you have more questions about this project, DM me on Discord and I can hook you up with August so you can ask more questions.
Did you come to yourself or? Okay. Oh wow. Okay, so I'm Roshan. I'm doing the finding security vulnerabilities in real world IoT devices. So essentially, IoT devices are like stuff like your smart cameras, like for example, like Ring or like Alexa or even some like car keys now. And our goal during this semester is pretty much to find vulnerabilities and pretty much hack them and show like a final presentation at the end. I don't know if anyone here has seen anything about this kind of stuff, but essentially, if you've ever seen a DEF CON conference video, it's like this huge hacking conference. There they have like stuff where they'll be like remotely taking down other people's drones, and they'll be like breaking into other people's cars, not physically, but like by hacking their car without a car key. Now, obviously, we won't do anything illegal, but that's kind of our main goal is doing some cool stuff like that. So yeah.
Hello. All right, guys. I'll talk a little bit about the motivation for this project. I've broken my arms 4 times. Let's go. Is that the arm you broke me with? Oh, nice. Okay. So basically, on the most recent one, I broke my scaphoid. If you guys don't know, it's a very important bone. If it's broken for long enough or broken correctly, it'll lose circulation to it, and basically your arm will like go black and like maybe fall off and stuff. Not super relevant, but basically, it was misdiagnosed 3 times, or misdiagnosed. Basically, X-ray professionals did not see the broken bone on the X-ray. I think this is an issue, so this is a very problem solution approach. It's very common that broken bones are not found on X-rays from medical professionals. So my aim is to use a state-of-the-art machine learning real-time object detection model, which is Logan 7, and I already found a data set, so we're good to go on that. So it'll be very fun. All right, thank you guys.
And so that is all of our projects. If you want to learn more about ACM research, we do have a Medium article out. So you can scan that QR code up there and just read more about ACM research and past experiences and whatnot. I'll give everyone a second to read that. Did everyone who did get it? Okay, cool. And with that, that concludes our presentation. Thank you so much for coming. I know that it is snowing outside, so I really appreciate y'all coming about it. Yes, that is Polish cow. He is our Was that our application?
It'll be high priority for me.
So having an internship's not really like a lower or higher priority kind of thing. It really, all applications are case by case basis. There isn't like a specific standard or something like that we're looking for. So I would, if you have internship experience, I would say just go ahead and put it on there. You're not going to be like having a lower chance based on it. Um, but yeah.
Yeah, I would say the more important thing would be to express interest, right? Like we have people like when I started, I had very little like hands-on experience or project experience in anything at all. Like I had projects, but it wasn't like anything like I did personally, right? But what the important thing was I showed interest in the actual application, and I was like in general, I was like just being a good human being. I think that's a huge part of being like having a good application because you really work with a team, right? You have a team of about 4 to 5 people, ideally, and you have to be able to work closely. That's a huge part of succeeding in research. So show interest and show that you can be working with the team well. I think that's the two things that would be really useful.
I think I saw your hand first. Yeah.
So for the travel visa, like you have an idea about how you would implement it, but you're not quite like experienced enough to actually code it. Would you have like a less chance of possibly getting an interview or being accepted if you don't code it?
No, it's really just because like I mean I'm assuming you would just want to write like a paragraph if I'm understanding. So like you're fine. You're not going to have any less or more chance. But I would highly encourage you to actually go out and like research how you would do it because by doing this coding challenge completely, it's actually kind of like a gateway into what you will be doing at ACM Research. So in ACM Research itself, you will be doing a lot of like reusing outside sources to learn how to do like specific parts of a project. So I encourage you to code, but obviously you don't need to code. Like I said before, I got in with like a 5 sentence paragraph. I'm a director now, so it's not going to be. You won't have any less of a chance if you do like a written paragraph of some sort. Indeed, yeah.
Okay, I haven't had any internships, so I guess I'll technically admit that. But the most coding experience I have is like some C++, plus plus, but I'm more than happy to learn more with Pythons. Is that something you guys are interested in accepting, or is that something that's like not as high a level priority?
Oh, so you want to learn more C++? Plus plus?
No, no, I'm open to learning more
Oh
different
yes,
programming languages.
yeah, that is exactly what we're looking for in our program. Like I said, it's mostly just for people who don't have much experience and are wanting to learn more. So our leads will be, kind of teaching you how to do different tools and different languages. I was just like you when I applied. I actually came into college as a pharmacology major, and I switched to CS, and then I applied to this program. So I had like barely any coding anything so that you're fine. We will be kind of teaching you more different languages and tools and whatnot. Any more questions? Yeah.
Is there a way we can choose like a specific research program to do? Or like, can we say we prefer one of these?
Oh, yeah. So on our application, we have an option for you to pick your top 30 projects. And 99% of the time, if you do get in the program, you will be in those top 30 projects, if not your first. There's actually, I don't think I've ever heard of an experience where someone has not gotten into their top 3 projects. So you'll be able to pick the project. Yeah.
Could we like hit stuff in our application that would help us be geared towards a specific project if we wanted to?
Oh yeah, sure. Like I said before, we have like a question at the end of the application that's like, is there anything else that you want to tell us? So I definitely encourage you to, maybe write like you're really interested in like one specific project.
Okay.
Or you can also talk to the lead of the project that you're interested in after this is done, and you can kind of express your interest there too. Anyone else? Yeah.
So I saw the posters outside. They look super cool. Tell us a little bit more about how those tie into the whole research.
Oh yeah, sure. So a big aspect of our ACM research is that we it kind of looked like this. This is Ben, Chris Shepard, and Rohan's poster from last semester. So everyone who's accepted in the program will be designing a poster like this, and it'll be out after the research symposium. We will be putting them outside on the wall in ECS South or ECS West, so that everyone can see, or you can take it home if you feel like it. We've had a couple people just kind of steal the poster and take it home if it belongs to them. So that's like the main thing that's like the final project. It's both the presentation at the final presentation night as well as this coaster. So yeah. Yes. Yeah, that's pretty much it. So if you are not going to code the coding challenge, I would suggest you kind of write a paragraph of like how you would do it if you were to code it, like the logic behind it, like how you would go about dealing with like classifying data set and whatnot. Does that answer your question? Yeah, so in the application, you will have like the link to the GitHub, and which is going to take you to the official GitHub page of the coding challenge. And so we ask that you create like a fork for that or like your own repository, and then put the link of that your own repository back on the application. And then that's all you need to do. You have until February 1st then to work on the coding challenge. But you will have your link to your coding challenge on the initial application itself.
Yeah. So one thing to kind of stress before that, please submit the application with the link to the coding challenge. You can still edit the coding challenge after you submit the application until the deadline, February 1st. But you got to submit the link with the actual application itself. Otherwise, we don't know which one's which.
Yeah, and people that do not submit this link will be automatically rejected because we have, like he said, we have no way of linking it back to you, and we just don't have the ability and time to just reach out to every single person that has submitted an application and be like, hey, can you email us a coding challenge? It's just too much work, and logistic wise, it's just not ideal. So please do that. We've had to automatically reject so many good candidates because of the fact they did not submit a coding challenge. So yeah. Yeah.
So at the end, near the end of the semester, are we doing both the paper presentation and the slides, or both or either one?
So you will be doing a slideshow. So when you're presenting it to the final presentation night in front of the judges, you will have like a slideshow with all your work. And then you will also have a poster. The poster won't be really presented in the final presentation night. It'll just kind of be like a thing that we just hang outside ECS West and ECS South, being like, hey, look, research, join ACM research kind of thing. Yeah. No, our coding challenge is very open-ended. Like you can put whatever on there. It's really just like a use your imagination kind of thing.
Let me add to that, okay? Use your imagination. Last semester, okay, I thought, okay, I want to blow up cars. How do I put blow up cars into my coding challenge, right? And then I kind of put two paragraphs that, okay, how do I blow up a car? How likely is a car to blow up? And then I was like, okay, I can't tell people, oh shoot, I mean blow up cars. So I said, what's accidents blow up cars? And so basically, what I'm trying to say is, no matter what you think, and that's just related to the themes, like stars or whatever else, just like, hey, let's say you're more interested in how likely a star is a supernova, or how likely a star is to crash into other stars, or whatever. You don't have to be coding. You just you show that you have a thought process that's related to research that you can go through it and say, okay, in my sense, we start some paragraphs or whatever. Yeah, we're just trying to look into your brain and see how you think, basically. Okay, I'm like, that's gonna be kind of confusing. Okay, well, that was last semester. Last semester there was a cover data set, so it was just like it was very introduction. Like he gave me some data sets really really wild, and asked me to go out and make this stuff like data set. Yes. Anything really that you show passion and interest, basically saying, hey, you know what, I'm actually interested in this and I want to be here. Because most people they put nothing in their notes or nothing, no effort in their ACM like coding challenge at all. And so literally, if you just put in the flavor text at all, I'm like, dang, this guy actually interested. So who knows? Might go a long way.
I think I saw his hand first. Sorry.
On the in the one of the parts of the form, like when so actually it's part of the ACM project, but like on that form where like if you got accepted more than one interview from either ACM projects or research or the other one. So I got a question about that form. So if I'm like say for example I got accepted for well actually say for example I did not get accepted for like ACM projects for interview, but I marked it as preferred. Would that mean that I won't get an interview for the research, ACM research?
No. So the form is only for if the case you do get accepted to like multiple ACM programs. But if you don't get accepted to multiple ACM programs, it's you'll just go to the one that you are accepted to. Yeah.
So for the research projects, there's like a lot of big words and heavy mathematics.
Yes.
So would I be able to do that and learn that? Because I came here and I just thought I would be like a code monkey. So I don't know if I'm gonna do that.
So the projects, I mean, because it's research, they're very like verbose, like just like daunting. I mean, I know like wow, this project is like bare metal 3D creating space. When he proposed that project to me, I was like, huh? But you know, once you like Elise will do a great job of explaining you the different steps and how they work. And going into the project, they're not as complicated as they sound. They're really just because it's very research and machine learning and you're kind of getting like your hands dirty, they are a lot of different verbose big words that makes it sound scary, but I promise you it's not. As someone who did have no experience in anything in computer science, I did at least when I was a participant, I did a project where we made a open AI thing that would guess your password if you gave it information. And just like the thought of that is very daunting. I feel like for someone who's never done that. But once getting into the project, there was very steps that takes you up to that final thing, and it's very structured. And they'll teach you how to get there. They'll give you resources for YouTube videos or Medium articles for any help that you need, and the leads will be there to help you get to the final product of what they're proposing.
Yeah, because like if we were to drive to like New York City to Los Angeles, that sounds ridiculous, right? But we, like as research leads, we're like your GPS. Like we're not gonna take you in a car and drive you to New York, but we can give you directions on how to get there and details and stuff like that. So we're here to help you out, regardless of like where you are in your research or anything. So just feel free to ask us questions, especially like in the middle of the project. We're here to help you out.
Yeah, you.
So for the coding challenge, is it fine if we try to answer one of the questions that is already in the GitHub, or do we have to come up with our own questions?
Oh no, so the questions that are on there are just kind of like examples of what you can answer. And you could use those questions if you want, or you can come up with your own. Like I said, the coding challenge is very use your imagination kind of thing, so it's just kind of go ham on it. Yeah.
The interviews are just behavioral, right?
Yes, it is just purely for us to get to know you better as an applicant that we wouldn't be able to see on like a written application.
Thank you.
Yeah.
So how long does the technical or the coding challenge take for me? Because last semester I started 15 minutes before the deadline, and I'm planning on doing the same this semester.
So typically we did for like a approximate time we put an hour, but it really won't take an hour. I did mine in like 20 minutes, so like it's not supposed to be too much time. I will tell you, the more time and effort that you put in the project, the more we see. Oh, this person is really like dedicated in like the project. So the coding challenge is basically also another glimpse to specifically about your project, or if you have any questions about like application or whatever, just come up and we'll be happy to help you all. But thank you so much. Have a good day. Stay safe. I know it's snowing and cold. Yeah. Yeah. So if you want to do that, yeah, we were only prepared to do the conference. This year. So yeah, you are API. So it doesn't cost. It's really just like conference. If you want to use that, you can use it for conference. Really not yeah, yeah. It's like but we consider because it's not a question. So it's not like
Yes, I can.
I guess you can tell me what you're now.